Okay. Now I'm going to present my topic, which is question 3 and 6. The topic of limitation of the graphical method for solving linear programming problem, and as well as explaining what constitutes the feasible solution area in LP model. I am going to explain this by using the Metropolitan Police Petrol case. Next. The graphical method is useful basic tools in linear programming, especially when we want to understand how constraints and objective functions interact visually. However, despite being simple and intuitive, this method has major limitation which make it unsuitable for more real-world problems. The first and most important limitation is that the graphical method only works when a problem has two-dimension variable, usually represent as x and y. Since we can only draw graph on a two-dimension plane, only LP problem with three or more variables cannot be solved graphically. The second limitation is that the method became harder to use when there are many constraints. As more constraint lines are added to the graph, the diagram became messy, difficult to read, and prone to shading mistake. It became challenging to identify the feasible region correctly, especially when lines intersect closely or overlap. Next. The graphical method also does not scale well, which is not practical for complex problems. Real life LP problems such as transportation planning, production scheduling, and resource allocation. Real life LP can involve dozens or even hundreds of variables. In such cases, a drawing graph is impossible, and we must rely on computer-based methods like simplex algorithm or interior point method. Another limitation is that the graphical method only works when all the constraints and the objective function are linear. If even a constraint non-linear, the feasible region would involve curve instead of straight line, and the graphical method became invalid. Here we can see how adding more constraint make the graph complicated in the complexity illustration. For an example, when constraints like x plus y are less than equals to 6, or x plus 2y less than equals to 8 are added, the feasible region became narrower and harder to interpret. This demonstrates how quickly the graphical method became impractical when more conditions are added. Next. Only two variables. The graph only works because the problems uses variable, and if we add a third variable such as a 2D graph is no longer possible. A 3D graph is now practical for finding optimal points, and real LP problems often have many variables, making graph impossible. This demonstrates the fundamental limitation of the graphical method. Next. Now we can move to the second question, which is the feasible solution. Next. Next. Okay. The feasible solution area in the region graph where all constraints are satisfied at the same time. In the Metropolitan Petrol case, each constraint represents a maximum allowable travel time for a petrol zone. Only the point that lie on the correct side of all these constraint lines form the feasible region. The key characters of intersects of constraints. The feasible region is formed by the intersection of every response time constraint and the non-negativity constraint x, which is x more than equals to 0 and y is more than equals to 0. Any point inside this region is considered a valid allocation of police patrol cars that meets all travel time requirement. The boundaries of the feasible region are formed by the most restrictive constraint. Some constraint will form do not affect the final shape at all. Next. Shape of the feasible region. Shape of the feasible region because the problem has only two variables, x and y. The feasible region form a complex polygon. In the polyspectral case, the polygon is shaded area shown in the graph. The most important part of the feasible region is corner point. In linear programming, the optimal solution, whether minimization or maximization, always occurs at one of these verticals. So, to find the best allocation of petrol car, we could evaluate the objective function at each of these corner points. Next. In summary, the feasible solution area in the shaded polygon where all the response time constant overlap. Every point within it represents a workable solution, but the optimum will always be found at one of the corner point. And while the graphical method helps visualize this, it is limited because it only works for tomorrow variable. Two variable becomes messy with too many constraints and cannot handle complex or non-linear program. That's all for my part. Thank you.